Good afternoon, class. This afternoon, we'll be talking about organic chemistry. And what is that particular topic that make all JAMB, WAEC, and NECO students panic most? It's called the isomerism. And what is isomerism? Isomerism is the existence of two or more compounds having the same molecular formula but different structural formula. So we have molecular formula but different structural formula. I will underline these two to explain the isomerism. If you have C4H10, this is called butane. And let's open the words. The molecular formula of butane, we have CH3, CH2, CH2, CH3. What you have here is the molecular formula. And what is the structural formula? We have 4 carbon atoms and 10 hydrogen atoms. So what you have here is a structural formula. Why this is the molecular formula. Then isomerism is subdivided into 2. Isomerism is subdivided into 2. The first one is structural isomerism, while the second one is stereoisomerism. With that, we have this structural, and here we have stereo. So under the structural isomerism, we have 4 types. The first one is chain isomer. The second one is position isomer. The third one is functional group, while the fourth one is metamerizing. Then for stereoisomerism, we have geometrical isomer and we have optical isomer. So let's pick this structural isomerism first. Then we explain the division under it. And mind you, for JAMB, WAEC, and NECO students, this structural isomerism and stereoisomerism is very important for you to tackle any question in JAMB, WAEC, or NECO. So what is chain isomer? Well, first and foremost, structural isomerism is the same thing with the definition of isomerism. With that, we can say structural isomerism is the phenomenon of 2 or more compounds having the same molecular formula but different structural formula. So what is chain isomer? Chain isomer differ in the way the carbon atoms are arranged. Example of chain isomer, we have N-butane, and thus we have C4H10. So under this chain isomer, we want to deduce if it can have another isomer under butane. So for butane, we have CH3, C2, CH2, CH2, and CH3. So it's this now. For this N-butane, I can have another compound which is CH3, CH. This is called 2-methylpropane, or we call it isobutane. With this, and note one thing under it, this N you have here is known as a normal butane, while the iso is a normal butane in the compound, and all the compound in organic compound under alkane, ethane, methane, propane, cannot undergo isomerism. The only compound that can undergo isomerism is butane, pentane, down to decane like that. Then the second one is position isomerism. These are those substituents in which they are positioned on the same carbon skeleton. Example. So we have CH3, CH2, CH2, OH. This OH is a what? Functional group. That is the hydroxy compound. I can call this compound propan 1O. Then when this particular compound move to the second carbon atom here, we have CH3, CH, CH3. So we call this compound propan 2O. So the position of the substituent might be the same thing, but the functional group will move from the first carbon atom to the second carbon atom. So here we have propan 1O, while this we have propan 2O. That is for position isomerism. Then the third one is functional group isomerism. Functional group isomerism, they have the same molecular formula but different functional group, and also they belong to different homologous series. Example, we have ethanol. This ethanol can also produce methoxyethane. So we have CH3, CH2OH for ethanol. You can see this is a molecular formula, and here is a functional group. So for methoxymethane we have CH3, CH3. This O is ethyl, which is the functional group. So you can see they have the same molecular formula. So if you want to check if truly they have the same molecular formula, you count the number of hydrogen atoms and the number of carbon atoms. Here we have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen. The same thing to methoxymethane. The last one is under structural isomerism, we call it metamerizing. They have the same molecular formula, functional group, but the methyl group that surround it changes. Example of metamerizing, we have C4H9, then we have oxygen. So the first formula that is CH3, OCH3, CH2, CH3. Then the second one, we have CH3, CH2, we have CH2, CH2 also. So now if we should count now, here we have 4 carbon atoms, 1, 2, 3, 4. Then our hydrogen must be the same thing with what you have here. So 3, 5, 7, and here should be what? 2. So we have 9 hydrogen atoms. So you can see now the functional group here is ethyl. When you look at this particular 2 compound, they have the same molecular formula, but let's say the methyl group surrounding this functional group is different. So here and here we have methyl group here, and here we have propy there, and also here is what? Methyl group. So from the definition that they have the same molecular formula and functional group, but the way the methyl group that surround those functional group arranged can change anytime. I can decide to place this my O here to this place. Then I can decide to put it here also. When talking about the stereoisomerism, these are those compounds that have molecular formula in different 3-dimensional orientation. That is for the stereo. That is, for every stereo, the way the carbon atoms are arranged in space. If I have 1 carbon atom here with different atoms attached to it, I can have this like this and also like this. So like we can call this 3D dimensional orientation. That is for the stereoisomerism. Then when talking about the geometrical isomerism, which is classified under stereo. For every geometrical isomerism, there are types of organic compound found to have double, triple, or a ring structure. And one thing you should note is, look at this. If I have one carbon atom here, I also have one here. There will be free rotation. Example now, a single carbon atoms. I can have one atom here, I can have one atom here, I can have one atom here. Also to the second one, 1, 2, and 3. Why? Because there is free rotation for that carbon atom to accept hydrogen. And if we should have two, we have a double bond attached to the carbon atoms. Like this two canal. If one carbon is here and another one is here, there won't be free rotation. So, with that, under the geometrical isomerism, we have the cis and trans. And the cis, the methyl group are alternate to each other. While for the trans, the methyl group, they are opposite to each other. So, example of trans isomer is called trans boots 2A. So we have CH3, our double bond. So this one is a good example of trans isomer. It is called trans boot 2A. How do we have it? When you look at the carbon atoms you have here, we have 4. And if you should number using the IUPAC nomenclature of organic compound, we place the first value here, we have 1, 2. That makes it what? Trans boot 2A. While the second one is cis boot 2A. So with that, CH3, the methyl group, and we have this. They are alternate to each other. So this one is called cis boot 2A. While this one is called trans boot 2A. So that is for the geometrical isomer. They can have double bond, triple bond, and a ring structure. And if they have double bond, triple bond, or the ring structure, is going to restrict their rotation. The last one is optical isomerism. And this optical isomerism is what we always see every day. If you should pick up your mirror, you look at it, you see yourself inside. So for this optical isomerism, they have the same molecular formula, structural formula, but cannot be superimposed on each other. The enantiomers in them cannot make them to superimpose on each other. And with that, we have one formula called lactic acid, which is known to be 2-hydroxy propanoic acid. We have one carbon atom at the middle. According to the definition of stereoisomer, that they have the same molecular formula, but the three-dimensional shape is being exposed in space. So if I have CH3 here, I have my alkanoic here, I have my hydroxy here, I also have my hydrogen atom here. This place here I aesthetic it because this is called a Sharia Carbon. Why is it called Sharia Carbon? Is because this Sharia Carbon here can contain as many atoms, be it any functional group or any organic compound. Probably like this one is what? Methyl. Here we have alkanoic, the functional group. We have hydroxy, and here we have hydrogen atom. So the Sharia atom or Sharia carbon can contain 4 different atoms. So it's that. I think I justify the part of organic compound under isomerism. Thanks you for watching. Don't forget to subscribe.